Hello and welcome everyone. Myself Vinay, the mathematics mentor. Hope you guys are doing much amazing. So in today's class, we are going to start with conic sections. So here we will see the basic definition of conic sections. With just one definition, we can be able to define parabola, ellipse as well as hyperbola, which are considered as the major portions of conic sections as well as of the coordinate geometry. So basically, whatever we are going to study in today's class is going to be used in parabola, ellipse and hyperbola individually when we will study individually these topics. So it means that this class is going to play a very crucial role in every three chapters, in all these three chapters, right? So let's see, while defining the conic sections, we must be aware about the locus. So what is locus? Locus is a moving point which moves in such a way that it follows certain geometrical conditions. And what is this geometrical conditions? For example, when we define circle, when we define circle, we have one fixed point known as center of the circle. This is the center of the circle. And what is the condition that follows the definition of circle is we have one moving point P, which we consider it as the coordinates we consider as h comma k, and this point P should move in such a way that its distance from this center, let's say this is center and its coordinate are, let's say, alpha comma beta. So the distance of point P from center C should always be equal. It means it can move in such a way that it has to follow the condition that its distance from the center C should always be equal, and that is known as radius r. So likewise, when we are tracing the points which follow certain geometrical conditions, we call it as locus. Likewise, we have to define parabola, ellipse and hyperbola. So here the geometrical condition is moving point P. This is the moving point P because it is going to follow a certain geometrical condition, right? So here the moving point P follows a geometrical condition that its distance from center C should always be equal, and that distance is known as radius r in case of circle. Similarly, when we will define conic sections, then we have to take care of two major points, and those are one fixed straight line and one fixed point. Now in case of circle we were having one fixed center. In case of conic sections, we will be having two major points, and those are, one is the fixed straight line and the second one is fixed point. Now let's assume our moving point P, whose coordinates are h comma k, as point P with h comma k as its coordinates. Then distance of this point P from this fixed point is going to be, the ratio of distance of this moving point P from this fixed point to its perpendicular distance from this point to this directrix, this fixed straight line, is always going to be constant, and this fixed straight line is known as directrix. We call this fixed straight line as directrix, and the fixed point is called as focus. This fixed point is called as focus. So with the standard notation, we denote focus with symbol S, and from here we take this point P. Now this is the perpendicular distance of point P from this fixed straight line known as directrix. So what the definition we are giving for conic section is, conic sections is the locus of a moving point P whose ratio from the fixed point to the perpendicular distance of this from fixed straight line is always going to be constant. So PS upon PM is going to be always constant, and that constant is going to be defined as with symbol small e, and small e is known as eccentricity. We call it as eccentricity. So let me explain once again. So what is the basic definition of conic section is, we are having two major points, that is, one is directrix, that is known as fixed straight line, and the fixed point known as focus. So the ratio of the distance of this moving point P from the fixed point to the perpendicular distance of this point P with this directrix is going to be always constant, and that constant is known as eccentricity E. So basically what we have derived as of now is PS is going to be equals to E times PM. So this equation is very, very useful, because with this equation we can define parabola, ellipse as well as hyperbola. So how can we differentiate How can we differentiate whether it is ellipse, parabola or hyperbola? Based on the constant known as E. If E is equals to 0, sorry, if E is equals to 1, if E is equals to 1, it will be defined as parabola. So basically, based on the value of E, if it is equals to 1, we will call it as parabola. If E lies between 0 to 1, if E is equals to 1, E lies between 0 and 1, we will call it as ellipse. And if the value of E is greater than 1, then we will call it as hyperbola. So as of now, we have seen the basic definition of conic section is PS upon PM is going to be always constant. And now that PS equals to E times PM, so based on the value of E, we can differentiate whether it is parabola, ellipse or hyperbola. If the value of E is going to be equals to 1, then it will be known as parabola. If the value of E is going to lie between 0 and 1, excluding both 0 and 1, then it will be known as ellipse. And if the value of E is greater than 1, it will be known as hyperbola. So now let's see how we will derive the equation. So we have, let's assume that fixed point to be alpha comma beta. Let's assume that fixed point to be alpha comma beta and the fixed straight line as the general equation of a straight line, and that is ax plus by plus c is equals to 0. So now we have taken fixed point as alpha comma beta and fixed straight line as ax plus by plus c is equals to 0. We are aware about the fact that PS is equals to E times PM. So how we can write PS? We have P coordinate as h comma k. P is the moving point, h comma k, and S is the focus, that is a fixed point. So we can write the using distance formula. We can write PS equals to, so we can write PS is equals to root over h minus alpha whole square plus k minus beta whole square, that is going to be equals to E times, and PM we can write the perpendicular distance of point P from this fixed straight line known as directrix. So we have point P, h comma k, and the equation of this straight line is ax plus by plus c equals to 0. So we know the distance formula. We can put this value h comma k in place of x and y. So we can write a into h plus b into k plus c divided by root over coefficient of x whole square plus coefficient of y whole square, like this. So now this is the definition of conic sections. If the value of E is equals to 1, it will be parabola. If the value of E lies between 0 and 1, it will be ellipse. If the value of E is greater than 1, it will be hyperbola. So with just one definition, we are able to define parabola, ellipse and hyperbola. So it means now we can square both sides. On squaring both the sides, we will be able to get h minus alpha whole square plus k minus beta whole square is equals to e square and ah plus bk plus c divided by root over, we can remove this root on squaring, it will be a square plus b square, and here it will be whole square. So now we can replace h comma k with, we can replace h comma k with x and y, x comma y. So our equation will become x minus alpha whole square plus y minus beta whole square, that is going to be equals to e square times ax plus by plus c whole square divided by a square plus b square. So upon changing the value of e, we will be getting the different equations of the conics. As we have seen, if the value of e is going to be equals to 1, it means that this equation is going to define parabola. If the value of e lies between 0 and 1, it will be defining ellipse, as well as if the value of e is greater than 1, it will be defining hyperbola. So now we have seen the basic definition of conic sections. Also we have seen how to differentiate based on this definition, that is PS equals to E times PM, how we can differentiate whether it is ellipse, hyperbola or parabola. Now we can see some of the good questions based on this topic concept itself on the definition part, so that we can be able to apply this equation PS equals to E times PM, and we can be able to know how it is defining the conics. So let's go with the questions. So let's start with the basic question based on the conic sections definition. So we have first question as, Find the equation of parabola, ellipse and hyperbola whose focus is -1 comma -2 and the directrix is the line x minus 2y plus 3 is equals to 0, given eccentricity of ellipse equals to 1 by 3 and eccentricity of hyperbola is equals to 5 by 4. So we need to find the equation of ellipse, hyperbola as well as parabola whose focus and directrix have been given. So let's see how we will solve this and how we will define and how we will derive the equation of parabola, ellipse and hyperbola. So we have the fixed straight line, the known as directrix, and its equation has been given as x minus 2y plus 3 is equals to 0, and the fixed point known as focus, its coordinates are given as -1 comma -2. Let's plot point P, that is known as moving point, with coordinate h comma k. Now we are aware about the definition that its distance from the focus is going to be e times distance from perpendicular distance from this straight line. So let's plot this PM. Now we know PS is going to be equals to E times PM. So as of now, it is a general equation of conics. We can't say it is parabola, ellipse or hyperbola. Once we will be aware about the centricity, once we will be aware about the values of this E, we can distinguish between parabola, ellipse as well as hyperbola. So now let's see, since we have to find each and every equation. So first of all, let's start with parabola. As we can see, we have been given the eccentricity of ellipse as well as hyperbola, but we haven't been given the eccentricity of parabola. Then how can we proceed? In that case, we must be aware about the fact that the eccentricity of parabola is always going to be 1, since we have already seen. So parabola, we know eccentricity is going to be equals to 1. It means that this equation has been turned into PS is equals to PM. So now we are aware about the fact that PS is going to be equals to PM in case of parabola. So we will do nothing but just follow the definition part itself. So we can write the PS value. Since we have coordinates of P also as well as the coordinates of S also, we can apply distance formula, nothing else. So now we can write PS value as h plus 1 whole square plus k plus 2 whole square is going to be equals to, we know the perpendicular distance formula, we have point P and the straight line, we can write h minus 2k plus 3 divided by coefficient of x square plus coefficient of y square, 1 square plus minus 2 whole square. We will take the modulus since we are considering the distance here. Now we can squaring both sides. So we can be able to write it as x. We can convert also h comma k to, we will replace h comma k with x comma y. Now our equation will be turned into x plus 1 whole square plus y plus 2 whole square is equals to x minus 2y plus 3 whole square divided by 5. Now this is the equation of parabola with focus -1 comma -2 and the directrix x minus 2y plus 3 equals to 0. So now this is the equation of parabola. What will get changed when we have to write the definition of ellipse as well as hyperbola in the same question? So in case of ellipse, these things will remain same. What will be extra term will be added here is, since we know PS is equals to E times PM, we can square both sides. We can write it as PS whole square is equals to E square times PM square. Now PS square and PM square we have already written here. We can just add the factor here, E square. Since we can write here as x plus 1 whole square plus y plus 2 whole square is equals to E square. E square, in case of ellipse, we have been given the eccentricity value as 1 by 3. So we can write 1 by 3 whole square multiply by PM square. PM square value is this much. So basically this is PS square and this is equals to PM square. Okay. Now we can write PM square as x minus 2y plus 3 whole square divided by 5. As of now, we have seen this much. So now this is the equation of ellipse. This is the equation of parabola. In case of hyperbola, what will be difference? In place of 1 by 3 whole square, we will have to write 5 by 4 whole square. That's it. So in case of hyperbola, I'm removing this part. So in case of hyperbola, So in case of hyperbola, we know for hyperbola we can write, to write the equation of hyperbola we can write PS square equals to E square times PM square. So we know PS square equals to this much values are known as PS square. So we can write x plus 1 whole square plus y plus 2 whole square is equals to E square means 5 by 4 whole square when we have to write the definition of hyperbola, multiply by PM square. PM square value is x minus 2y plus 3 whole square divided by 5. Now this is the equation of hyperbola. So we have seen as of now, when we have to write the equation of parabola, ellipse or hyperbola, we have to take care of the centricity value. Once we will change the value of E, we will shift from parabola to ellipse and from ellipse to hyperbola. So what is the important point here we have noted is to write the definition with focus and directrix. We need to write the distance formula. We need to apply distance formula to get this distance and the perpendicular distance formula to get the distance of PM, and we will multiply with E based on parabola, ellipse and hyperbola. So we have taken the first question, we have seen the solution also. So let's see our second question based on Focus-Directrix definition. The definition which we have seen is also known as Focus-Directrix definition because we have taken 2 points, that is focus as well as the directrix, to define our conic sections. That's why it is known as Focus-Directrix definition. So based on this same very definition, we have the question, let P be the parabola whose focus is minus 2, 1 and directrix is 2x plus y plus 2 is equals to 0. Then the sum of the ordinates of the points on P whose abscissa is minus 2 is, we have 4 options. It has been asked in JEE Mains 2025. This question belongs to this year JEE exam itself. So let's see about the solution. We have been given one directrix. The equation of directrix is 2x plus y. The equation of directrix is 2x plus y plus 2 is equals to 0. We have fixed point known as focus. The focus is minus 2, 1. Focus is minus 2, 1. Now we need to find, we have been given, let P be the point. We have been given point P whose abscissa is minus 2 and we are unaware about the ordinates. The x coordinate of any point is known as abscissa and the y coordinate of any point is known as ordinate. So we have been given the x coordinate as minus 2 and we haven't been given the y coordinates. Now we need to find the possible values of k. We need to get the sum of these possible values of k. That will be our answer. Since we are aware about the fact that this distance PS, this is point P and this will be M. So in case of parabola, we know PS is equals to PM. Since E is equals to 1 for parabola. Now we are aware about the fact that PS is equals to PM. We will apply the formula. Now we can write PS value as PS is equals to minus 2 0 square plus k minus 1 whole square is equals to PM. We can write the value of PM as 2 multiplied by minus 2 plus k plus 2 divided by coefficient of x whole square 2 square plus coefficient of y square, that is 1 square. Now from here we can square both sides. So squaring both sides, we will be getting here k minus 1 whole square is equals to k minus 2 whole square divided by 5. 2 square plus 1 square, that is 5 plus square, so it will be 5 square, that is 25. Now we can write 25 times, here we can write k square plus minus 2k plus 1 is equals to k square minus 4k plus 4. From here we can write, so I'm sorry here, this will be under root, so here we will be getting 5 itself, my bad. So here we can write, since it will be under root a square plus b square, so now on squaring this under root will get vanished, so it will be just 5. So now we can write 5 times this one, and after solving we will be getting 4k square minus 10k minus 4k, it will be plus 4k, so minus 6k plus 5 minus 4, it will be plus 1 equals to 0. Now we need to find the sum of the ordinates. So it has 2 possible values. Since it is a quadratic, k1 and k2, we need to find the value of k1 plus k2. We know if we have a quality equation ax square plus bx plus c equals to 0, if it has two roots alpha and beta, the sum of its roots alpha plus beta equals to minus b upon a. In this case, it will be minus of minus 6 upon 4. It will be 3 by 2. So 3 by 2 is our final answer. Option B is correct. So what we have done is, we have just applied the Focus-Directrix definition, that is PS equals to E times PM. In case of parabola, we have the eccentricity value as 1. So we can write it as PS equals to PM. So now we will find the value of PS. So we can write 0 square plus k minus 1 whole square is going to be equals to, distance formula applied here. So minus 2 into minus 2 plus k plus 2 upon root over 2 square plus 1 square. After solving, we got 4k square minus 6k plus 1 equals to 0. Since it has been asked that we need to find the sum of the ordinates of the points. Since we know it is a quadratic equation, it will be having two roots named as k1 plus k1 and k2. And we know that if we have a quadratic equation ax square plus bx plus c equals to 0, if it has two roots alpha and beta, then the sum of its roots, that is alpha plus beta, is given by minus b upon a, where b is the coefficient of x and the a is coefficient of x square. In this case, we got minus 6 plus upon 4, it will be 3 by 2. So hope you will understand, you got this question very deeply. Try to solve by yourself as well. So let's see our next question. Let's read the question. Find the locus of a point P x comma y such that the ratio of its distances from the point 2 comma 0 and the line x equals to 6 is 1 by 3. Also identify the conic name. So we have been given one fixed point. So we have been given one fixed point 2 comma 0 and the line x equals to 6. We need to find the ratio of moving point P x comma y. So here we have been given the equation of line is x is equals to 6 and the focus is given as 2 comma 0. Let's say it is S. We have moving point P x comma y. We need to find the ratio. What ratio? Let's see, this is perpendicular distance PM. So such that the ratio of its distances from the point 2 comma 0. From 2 comma 0 means it will be PS divided by, and the line x equals to 6. So when we need to find the distance of point P from the line x equals to 6, we can write it as PM. So PS upon PM is 1 by 3. So ratio has been given as 1 by 3. So this is equals to 1 by 3. This has been given in the question itself. Next is also identify the conic name. Now we need to find this conic name. Since we are aware about the fact that PS is equals to E times PM, from here we can write PS equals to, PS equals to 1 by 3 times PM. After comparing, we got E equals to 1 by 3. Since eccentricity value is lying between 0 and 1, it means this conic section, this conic will be known as ellipse. So it is ellipse. Conic name is ellipse. Conic is ellipse. Now we need to find the equation of this conic also. Since we need to find the locus, it means we need to find the equation. So what we will do, again we will put the value. So PS equals to 1 by 3 times PM. We can write PS square equals to 1 by 9 times PM square. From here we can write PS square will be x minus 2 whole square plus y minus 0 whole square, that is y square, is equals to 1 upon 9. PM will be, it will be x minus 6 upon 1 whole square. It will be whole square. So after solving, we got x square minus 4x plus 4 plus y square, 9 will come here, left hand side. Here we can write x square minus 12x plus 36. After more simplification, we can rewrite it as 8x square plus 9y square. Here we can write it as x minus 2 whole square plus y square equals to 1 by 9. Here we can write x minus 6 whole square upon 1 square, that will be x square minus 12x plus 36. So it will be 8x square plus 9y square. From here minus 36x, here it is minus 12x, so 12 come here, minus 36, that will be minus 24x, rest 36 and 36 will get cancelled out. So this will be our final equation. This is the equation of ellipse. Equation of ellipse. Since we have seen in the definition that conics are the locus of moving point P whose ratio from of point P with the focus S to the perpendicular distance with the directrix is always going to be constant. In this case also, we can see here we need to find the locus of point P such that the ratio of its distances from the point P from point S, that is focus, correct, to comma 0. In this case, we saw that eccentricity value is going to be equals to 1 by 3. Eccentricity is 1 by 3 means it's the ratio of its distance from focus to its perpendicular distance from its directrix is going to be equals to 1 by 3. It means eccentricity value is lying between 0 and 1. It means that it is going to known as ellipse. Also, we have find the equation of ellipse by just writing the equation PS equals to 1 by 3 times PM. After squaring and simplification, we got this equation 8x square plus 9y square minus 24x equals to 0 as the final equation of the required ellipse. So let's move towards our next question based on Focus-Directrix definition itself. So you can see how important the definition of conics is. So this question has been asked in JEE Mains 2022. The question is, if the equation of a parabola whose vertex is at 5, 4 and the directrix is 3x plus y minus 29 equals to 0 is x square plus a times y square plus b times xy plus c times x plus d times y plus k equals to 0, then a plus b plus c plus d plus k is equal to, we have been given the 4 options. So we have one more point here, that is vertex. As of now we have seen the focus and directrix. So let's see the definition of solution of this question. So once we plot the parabola, let's say this is a parabola. So we have focus here, let's say alpha comma beta, and this is known as directrix. This is known as directrix, and this point is known as vertex, and this point has been given to us in this question. Directrix has also been given. So we know any point P, if you take any point P on parabola, so this distance PS will be equals to PM in case of parabola. So if you take any point P on parabola, so the distance of P from S is equal to the perpendicular distance of point P from this directrix. Now we have been given vertex and this equation. So since we know the equation of directrix, we know the slope of directrix also. It means we can find the slope of axis of parabola. Since these two lines are perpendicular to each other, and we know if two lines are perpendicular, then the product of slopes of their if two lines are perpendicular, it means the product of slopes of their lines will be equal to -1. From there we can find the slope of axis, and we have one point, that is vertex. From there we can write the equation of axis, right? So let's move towards our question. Let's plot the points. So we have been given vertex as I guess it's 5, 4. So this point is 5, 4. Vertex is 5, 4, and equation of directrix is 3x plus y minus 29 equals to 0. Now, if we know PS equals to PM, let's say this point is A and this point is B. Since point A is also lies on parabola itself, we know PS equals to PM in case of parabola. Point A is also lying on parabola itself. It means distance of point A from focus, AS, is equals to perpendicular distance of point A from directrix, that is AB. It means AS equals to AB from definition of parabola itself. It means A is the midpoint of B and S. Also it means the vertex of a parabola is the midpoint of, we can generalize this as vertex of a parabola is the midpoint of point of intersection of directrix and axis and focus. So we will take this advantage in solving this question. Now we will write so from here we can write slope of this line equals to minus of coefficient of x upon coefficient of y. Coefficient of x is plus 3, coefficient of y is plus 1. So it will be minus 3. It means slope of axis will be 1 by 3. So from here we can write slope of axis is equals to 1 by 3. Now we can write the equation of axis as well. So equation of axis, it will be y minus we need to write the equation of axis. This is the axis of parabola. Axis of parabola. Axis of parabola. This is we have drawn this parabola, but it is not sure that this parabola will be opening towards right only. It may be any parabola, but we have just plotted the parabola with given values. So here we need to write the equation of axis of parabola. We have 1.5, 4 lying on this axis as well itself, and we know the slope. So we can write y minus 4 equals to slope of axis is 1 by 3 times x minus 5. From here we can simplify it as 3y minus 12 is equals to x minus 5. We can rewrite it as x minus 3y plus 7 equals to 0. Let's say this is equation number 1. We have the equation of directrix as equation number 2. Don't get confused with square. So this is equation number 2. Simplifying equation number 1 and 2 to get point of intersection of directrix and axis. So from here we can multiply equation 2. Let's multiply equation 2 by 3. So we can write 9x plus 3y minus 87 equals to 0. Let's say this is equation number 3. After solving 1 and 3, so let's add these two equations. Equation 1 plus equation 3, we got 10x plus minus 80 equals to 0. My plus 3y will get cancelled to minus 3y. From here we can write x is equals to plus 8. Now we can put the value of x equals to 8 in any of the three equations. Let's put in equation number 1. So we got, from here we can write 8 minus 3y plus 7 equals to 0. From here we can write y equals to 15 by 3, that is equals to 5. So y will be 5. So we got the point of intersection of directrix and axis as 8, 5. We got this point. Now, since A is the midpoint of B and S, so we can find the coordinates of focus as well. Let's see how we will do. As of now, what we have done, we know the equation of directrix, and we know axis of parabola is perpendicular to the directrix. So we got the slope of axis from here. Since slope of directrix is minus 3, so slope of axis will be plus 1 by 3, right? Makes sense. And we have point 5, 4 lying on the axis of a parabola. Since this is the vertex, so it will be lying on the axis itself. Now we can write the equation of axis, since we have point 5, 4 on the axis and we have slope plus 1 by 3. From there we got the equation of axis. Now we are finding the point of intersection of directrix and axis. Why we need to find this point of intersection? Because we will apply the condition that vertex of a parabola will be midpoint of focus and point of intersection of directrix and axis. From there we can calculate the focus. After calculating focus, we can apply the directrix focus equation definition to find the equation of parabola, and later on we can compare with the given equation to find the variables a, b, c, d and k. Correct? So let's move further. So as of now we got the point of intersection of directrix and axis as 8, 5. Now we know vertex is a midpoint, so we can write 8 plus alpha upon 2 is equals to 5. From here we can write alpha is equals to 2 and 5 plus beta upon 2 is equals to 4. From here we can write beta is equals to 8 minus 5, that is 3. So we got the focus as 2, 3. 2, 3. Now we got the focus 2, 3. We can apply the formula that PS equals to PM. So now PS is equals to PM in case of parabola. So write the definition part, x minus 2 whole square. We can square both sides, so PS square equals to PM square. So x minus 2 whole square plus, let's say this x comma y is the moving point, so we can write x minus 2 whole square plus y minus 3 whole square is equals to PM square. We can write the perpendicular distance of point P from directrix. It will be 3x plus y minus 29 whole square divided by 3 square plus 1 square. Now it will be equals to 10 times x square minus 4x plus 4 plus y square minus 6y plus 9 is equals to, squaring here also, 9x square plus y square plus 841. 29 whole square will be 841. From here we can write a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So from here we can write plus 3 2 is 6, 6xy plus taking this 2. So 29 into 2 into y, it will be minus 58y. Now take this one. 3 into 2, 6x multiplied by minus 29. 6x multiplied by minus 29. So it will be minus of 9 6 are 54, carry 5. 6 2 are 12 plus 5, 17. Minus 174x. So it will be minus 174x. Okay, now we can simplify it as 10x square, 9x square. It will be x square plus taking the x square term. From here we got 10y square. From here we got y square. So overall it will be 9y square. Take the coefficient xy term. From here no xy term. From here we have plus 6xy. It will be minus 6xy. This has been used. This has also been used. This is used. Now take the coefficient x term. So we got from minus 40x from here. And we got minus 174. It will come as plus 174. 174 minus 40. It will be minus 134. Minus 134x. This has been used. This term has also been used. Take the coefficient term of y. From here we got minus 60y. And here we have minus 58. It will come as plus 58. So minus 60 plus 58. It will be minus 2y. Now this is used. This has also been used. Now constant term is remaining. So we have 9 plus 4 as 13. 13 into 10, 130. Plus 130 and here plus 841. So 841 minus 130, it will be 117. 117. It will be minus 711 equals to 0. Now we can compare this equation with the given equation in the question itself. So we can compare and get. After comparing, we can write on comparing, we can write x square is equals to 1. So no, from here we can write a is equals to coefficient of y square is known as a. This is going to be equals to 9, and b is the coefficient of xy. So from here coefficient of xy is minus 6. C is the coefficient of x. From here coefficient of x is minus 134. So C will be minus 134. D is the coefficient of y. So from here coefficient of y is minus 2. And k is the constant term. From here constant term is minus 711. Now we can get the sum of all these numbers. So it will be 9 coefficient of a is 9, and okay, from here it will be minus 60 plus 58. Okay, minus 60y plus 58. Okay, from here we can write it as 9 minus coefficient of x. I think something is missing here. Coefficient of x will be minus 40x minus 174. It will be plus because minus 174 will come as plus in this side. So it will be plus 134. So here coefficient of c will be plus 134. Now we can write a plus b plus c plus d as 9 plus 134 minus 6 plus 2 plus 711. It will be 143 minus, it will be 6 plus 2 8. 711 plus 8, it will be 719. On simplification we can get minus of 9 minus 3, it will be 6. 11 minus 4, it will be 7. And 6 minus 1, it will be 5. Minus 576 is the right answer. Finally we got minus 576 as the sum of a plus b plus c plus d plus k. So what we have done in this question is, so we can see in JEE Mains 2022 it has been asked. So we can see how this was a little lengthy question. So we should be ready with for the calculative question as well, because it can be asked in question, and the logic was very simple that we need to find the focus and we need to apply the Focus-Directrix definition on this question. So to write the definition, to write the equation of ellipse, sorry, to write the equation of parabola, and then we can compare with the given equation to find the coefficients of each terms, and then we can sum up the terms to get minus 576 as the final right answer. So it was one of the calculative question of JEE Mains that has been asked. So we should be ready with calculation part as well. So our calculation should be very much clear. It should be fast and correct. So that's efficiency of solving the question should be right. So let's see our next and the last question of this lecture. The question is, which of the following point does not lie on the hyperbola whose directrix is 5x plus 9 equals to 0, eccentricity value is 5 by 3 and focus is at minus 5 comma 0, and we have been given 4 points. We need to identify whether these points lie on the hyperbola or not. We need to identify which of these given options the point does not lie on the given hyperbola. So what we need to do is, I guess this question should be, you should be able to solve this question. We have already discussed all the concepts. So let's see. We have been given the equation of directrix as 5x plus 9 equals to 0 and the focus is at minus 5 comma 0, and we know that let's see moving point P as h comma k to be with coordinates h comma k. In case of hyperbola, we will go with the general conic equation, Ps equals to E times Pm, and here we can write Ps value as h plus 5. We can write Ps whole square equals to E square times Pm square. Now Ps square will be written as h plus 5 whole square plus k square is equals to E square means 5 by 3 whole square. It will be putting here 5h plus 9 upon 5 modulus, so it will be whole square. So now we can simplify it as, after simplification what we can get is, we can write x square, let's replace h comma k with x comma y. We can write x square plus 10x plus 25 plus y square equals to 5 square will get cancelled out with this 5 square, and here it will be 1 by 9. 25x square plus 9 5s are 45 into 2, 90x plus 81. This main terms will be remaining. After simplification we can write 9x square 25x square. Let's write it as 9x square plus 9y square plus 90x plus 225 equals to 25x square plus 90x plus 81. From here we can write 16x square minus 9y square. This has been used, this many terms have been used. Now 90x will get cancelled out with 90x. From here we can write as 16x square minus 9y square minus 5 minus 1 4, 12 minus 8 4, 1, so 141 equals to 0. So this is our final equation of the hyperbola. So this is the equation of required hyperbola, Now we have been given 4 points. We need to identify which of the given point does not lie on this hyperbola. So 3 of these points will be satisfying this equation and 1 will not be satisfying. So we need to find that 1 point. So let's start with point A. So to check point A, we have minus 5 comma 16 by 3. Let's put x equals to minus 5 and y equals to 16 by 3. So we can write it as 16 into x square will be 25 minus 9 into y square will be 256 upon 9 minus 144. It should be equals to 0. If it is not, it means this point does not lie on this equation. So here it will be written as 25 6 are 150, carry 15, 25 into 25, 25 into 1, 25 plus 15. It will be 400. Just a second. So basically it will be 400 minus 256 minus 144. I guess this many term will be 400. So it is satisfying actually. So this is satisfying. Point A will satisfy the hyperbola. Let's check with point B. So 16x square, 16 multiplied by x square means 16 minus 9y square, minus 9 into y square means 16 upon 9 into 7. Makes sense? And constant term will be minus 144. Let's see if it is equal to 0 or not. So it will be 256 minus 16 sevens are I guess it's 7 6 are 42, carry 4. So it will be minus 112 minus 144. So 256 minus this term will become 4 plus 2 6, 4 plus 1 5. It is actually 0. It means this coordinate is also lying on the given hyperbola. So let's check point C. Point A and point B, as of now we have seen these 2 points are lying on the hyperbola. Let's see with the point C. Let's check point C. Let me write the equation which we have obtained. 16x square minus 9y square minus 144 equals to 0. Now we can remove. So let's check point C whether it is lying on the hyperbola or not. So 16 into x square means 36 minus 9 into y square means 4 for just 16 carry 16 multiplied by 2, it will be 32 minus 144. Let's see. 16 6 are 96. 16 6 are 96, carry 9. 16 3 are 48. 48 plus 9, it will be 57. Minus 9 2 are 18, carry 127 plus 128 minus 144. 576 minus 8 plus 4 12, 8 plus 4 12 plus 113, 2 plus 1 3 4. So actually it is not equals to 0. It means it is not satisfying this equation. It means it is not lying on the hyperbola. So point C will be our right answer because it is not satisfying. We can cross check with option 4 as well, but in this case it is not required because we have already found the point C which does not lie on this. Just to be sure, let's check with point D also. So point D, so 16 into x square means 36 minus 9 into y square means 16 3 are 48 minus 144. Let's see here, it will be 16 6 are 96, carry 9. 16 3 are 48 plus 9, it will be 576 minus 9 8 are 72, carry 7. 9 4 are 36 plus 7, it will be 43 minus 144. So 576 minus 4 plus 2 6. So it is satisfying actually. So point D also lying on the given hyperbola. So only one point, that is point C, does not lie on the given hyperbola. So what we have seen, we have first derived the equation of required hyperbola. How we have derived that? We were given directrix, we have been given focus, as well as we have been given the eccentricity as well. So we have used the basic formula of general conic, that is PS equals to E times PM. We can also write it as PS square equals to E square times PM square. From there we have find the equation of hyperbola, and that is 16x square minus 9y square minus 144 equals to 0. Thereafter we need to check all these 4 points. Out of these 4 points, one point does not lie on this hyperbola. We need to find that point, and we have checked and we have found that A, B and D lies on this hyperbola while point C does not lie. So option is point C. So as of now we have gone through the basic definition of conic sections, and where we have seen using Focus-Directrix definition of a conics, we can write the equation of parabola, ellipse and hyperbola. All these can be equations can be written. How we have been written? We need directrix and we need the focus. Also we have seen the question where focus was not given. Instead of that we have been given vertex. So we have utilized the result that vertex of a parabola is going to be the midpoint of focus as well as the point of intersection of directrix and axis. So like this we have used the results and we have derived the equations of parabola, ellipse and hyperbola in different questions, in different scenarios. And also we have seen the importance of PS equals to E times PM. So from today onwards we should be clear that whenever we have been asked to write the equation of any conics, whether it is parabola, ellipse or hyperbola, we should be aware that we have to take the equation PS equals to E times PM. If it is parabola, it means that the eccentricity value will be equals to 1. That means PS is going to be equals to PM. In case of ellipse, eccentricity value is going to lies between 0 and 1, excluding 0 and 1. So we can write PS equals to E times PM, and in case of hyperbola, eccentricity will be greater than 1. So there also we can write PS equals to E times PM with eccentricity greater than 1. So we can apply the basic equation PS equals to E times PM whenever we require to write the general equation of conics. So as of for today, keeping this much, revise all the questions once again, do by yourself, so as to gain much confidence. Now you will be getting more clarity once you will you will solve by yourself. So meeting you in next video. Till then, take care. Bye bye. Have a good luck.